Sorry, my iPad ran out of storage, so this just kind of appears, I'm sure, on the video. So this cotangent, I rewrote it as cosine over sine. And so I was just about to cancel these signs when I realized that my iPad had stopped recording. So here's where we're at so far. Right now we have 2 cosine equals root 3. I can get cosine by itself just by dividing each side by 2. So we get that, and that's a unit circle value that we should recognize. So root 3 over 2, that is the 30-degree family, but remember we're talking radians here. So that is the pi over 6. You want to make sure you include everything all the way around the circle. So cosine is also positive in the 4th quadrant. So the pi over 6 family member in the 4th quadrant is 11 pi over 6. All right, number 4, we've got sine here, sine here. This is also a cosine squared. So what we're going to do with this is we can factor out a common sine to the 4th. You'll see what I'm doing with this in a minute. I'm sorry, a common sine squared. So we can take out even the 4 with it if we wanted to. So these 2 pieces on the left-hand side, when we factor out this 4 sine squared, we have just a sine squared plus, and then you'll see we have a cosine squared. So the reason that I did this is because this is the Pythagorean identity, and what I have underlined there is just equal to 1. So multiplying by just the 1 that is leaves me with just this piece, times 1 technically. And then solving for sine, divide both sides by 4, so we get 1/4, and then square root, and don't forget when you square root, you've got to have the plus or minus because you'll lose half your answers without it. So square root of 1/4 is 1 over 2. So we're looking for every 1 over 2, positive or negative. So that could be all 4 quadrants. So in the first quadrant, that's pi over 6, right? Or the same as 30 degrees if it helps you to kind of think of degrees first and then translate. So we want every pi over 6 family member. So the second quadrant, 3rd quadrant, and 4th quadrant. So some overlap actually with number 41. All right, 43. So this one, you should recognize secant squared minus 1. That's actually a slightly rearranged version of a Pythagorean identity. That tangent squared plus 1 is equal to secant squared. So if I have secant squared minus 1, I can just replace that with tangent squared. Okay, so we're going to solve this by taking square roots, but first we would have to divide both sides by 3. So we have 1 over 3, and then I'll solve this by taking a square root. So tangent, I start with my plus or minus, and then the square root of 1/3, I have 1 over the square root of 3, and I can rationalize that. So I have plus or minus, so all 4 quadrants. And when I rationalize, I multiply by root 3 over root 3. So this is what I'm looking for. That's one that you should recognize as also pi over 6. The tangent of pi over 6 is root 3 over 3. And I want to take actually the exact same values that I have from 42 because I do have the plus or minus. So you take every pi over 6 family member from all 4 quadrants. So same exact solution set as I just had with number 43. All right, one last one here. So this one we've got a sine squared, we have a cosine of 2 theta, and then this is a cosine squared. So we've got a couple things that we can do here. I would get everything in terms of cosine. So sine squared, remember sine squared you can write as 1 minus cosine squared. Okay, so that's the sine squared, right? We've got 1 minus cosine squared. And then plus, so now the cosine of 2 theta, we can write as 2 cosine squared minus 1. And then you have minus 3 cosine. We got a lot of things here. And then since we've got quadratics involved, we might as well go ahead and subtract the 4 over to the left-hand side because we're going to end up factoring it. So let's combine our like terms. So for the squareds, we just end up with a cosine squared. This is our only cosine. So we have minus 3 times cosine. And then our constants, we have a 1, a -1, and a -4. So now once we use all those properties, this is just perfect for factoring because it's just a cosine squared And so we can factor that down like cosine times cosine, and then what multiplies to a -4, what adds to a positive, I'm sorry, -3. So cosine times cosine. So multiplying to a -4 and adding to a +3. So you have those two pieces. So take each one of these, set it equal to 0. Okay, so add 4 to both sides here. This one we should start to recognize anytime that cosine and sine are bigger than 1, there's not going to be any solution for that. Cosine will never reach 4. It maxes out at 1. And subtract 1 here. So this is going to be an x-coordinate of -1. So that's the furthest left point on the unit circle. So the furthest left point has a radian value of pi. So just one solution out of all of that.